So you will remember yesterday we started our little look at velocity time graphs. And yesterday we calculated average acceleration. And how did we do that? Looking at slope. We looked at not average velocity. We looked at instantaneous velocity. And how did we do that? Read it off the graph. And instantaneous acceleration, again, we're finding the slope, and we may have to use a tangent if the line is curved. That's what we just did. So today we're going to look at displacement and average velocity. This was yesterday, and I do need to break this into two. Okay, so here we are on the one that displacement says. Now, again, stay with me here. So displacement on a VT graph is determined by calculating the area between the graph and the time coordinate, and I always say to myself, fix that, because people don't know what that means, the time axis over the time interval in question. So I would like you to highlight that, star it, underline it, do something. It is the area between the graph. In calculus, they call this the area under the curve. We don't normally say that in physics because the curve could be underneath the axis. And then the area is above the curve axis. So it's technically the area between the graph and the time coordinate. They call this in calculus, for those of you that are going on, they call this integration. And when you do this, you're taking the integral. Oh, and it's got a fancy little symbol. So when you get there, you'll go, oh yeah, I remember this meant after that. In the example, the displacement for the time interval A, 0 to 2 seconds, would be equal to the area of the triangle formed by the graph from the time coordinates. So if I ask you for the displacement for time interval A, which is from 0 to 2 seconds, you go from 0 to 2 seconds, and then you go up to the graph, and you create a geographic figure. In this case, it is a triangle. It's the area between the graph and the time coordinate. And the formula for area of a triangle is 1/2 the base times the height, or base times height divided by 2, which are the same thing, right? 1/2 the base times the height, or base times height divided by 2. So what is my base from 0 to 2? And the height of my triangle is to 4. So 1/2 of 2 times 4. 2 times 4 is 8. Times a half is 4 what? 4 meters. Why meters? Well, first of all, it's displacement. Sorry, Danielle? The seconds do cancel out. Well done. If you multiply here, right? Here you've got 2 seconds in meters per second. So if you take seconds multiplied by meters per second, the seconds cancel out and you're left with meters. Okay, so the units are important. It's going to show you what it's going to be. Now, what do you do if there's more than one time interval to be used? Like, what if I ask you for the displacement between 0 and 5? What do you do? Do you have to color it in, by the way? No, I'm just doing this for visual effect. You got to do them both. If more than one time interval is to be used in the calculation of displacement, then the total displacement is the sum of the displacements of each time interval. If the displacement for the intervals A and B to be calculated, the following technique would be used. So the total displacement would be the displacement of A plus the displacement of B, which in this case is blue. Okay, so the area of A we already know is 1/2 2 times 4, which is 4. Right? How do I find the area of the blue figure? Well, this one is a rectangle, and we all know the area for a rectangle is length times width, or base times height, I guess, if you want, right? How far is it from there to there? 3, right? 5 subtract 2, that's your run in the slope, right? So it's 5 minus 2 is 3, times 4 is the height is 12, for our total displacement then would be 16. Okay, the displacement here is 16. It's not particularly hard. We're finding the area of the triangle, and we're finding the area of the rectangle. Good, Talia? Yeah? Taryn? Ladies there at the back, Tasha, yeah? Okay. Now, what do you do if the graph is below the time axis? The displacement is negative, that's all. Because when you're down here, the velocity is negative, which means you're moving to the left, so your displacement is going to be negative, right? So for example, the displacement for time interval D would be calculated as shown below. So this was C, this is A, this is B, this is C, so D is right here. Now, the most common mistake I see on this test is people doing this. And they shade below. Why is that wrong? It's not between the graph and the axis. It's between the graph, which is there.
Wait.
Let me do it with color so you can see it. Yeah?
Why are we using seconds as meters? When you count the squares on them, weren't you using seconds?
Well, not, that's just the base, right? Let me just show you here. Okay? So first of all, I'm talking about, it's from interval D, so it's from 7 to 8.5. So we're talking about this blue guy right here. So it's, again, between the graph and the axis. If it's below, you go above. If it's above, you go below. Do the opposite. Okay, so how far is the base rising? So it's from 7 to 8.5. So the base is really 1.5, and that's measured in seconds.
Oh, okay.
Okay, right? But the height is down to -3, so times by -3, but that's measured in meters per second. Seconds cancel. 1.5 times -3 would be -4.5 meters, and it should be shown right. Oh, hang on, what did I do here? Oh, I know what I did wrong. I'm one of the common mistakes. What did I do wrong? No, I drew the triangle in the right spot. This is the correct answer.
You didn't divide by 2.
I didn't divide by 2. I said it was a triangle, and then I just went base times height, right? Because I got excited about Riley's question about units here, and I forgot that it's the area of a triangle, so it's 1/2 times that. Right, so it's half of that guy there. Okay? Are you going to have any other figure other than a triangle and a rectangle? There will be no circles.
There's a slope.
If there's a slope, then we get into calculus, so I tend to avoid those. Basically, triangles and rectangles is what I'm saying. Okay, can you do area of a triangle? Yeah. Can you do area of a rectangle? Yeah. About grade 4 or 5, I think, right?
You make like a weird point.
You could, yeah. Yeah, you could have a trapezoid. Okay, ready to try some? So I want you to find the displacements for all remaining intervals. They are interval C. Question 1 is C. I've highlighted it here. Question 2 is E. I've highlighted it here. It's the same graph that you have, yes. Interval F is highlighted there. So you've got 3 to do, I think, right? And I just pushed. Oh. It's hard to figure out the... Okay. Whenever the average velocity is to be calculated, under any circumstance, it must be done using the formula v bar equals d over t, where the displacement is calculated from the bt graph using the area under the curve technique. So, in English, average velocity, you have to find the displacement first, and then divide by the time. Here's what kids want to do. It's wrong. I'm not even know if I want to show you. Should I show you what they do wrong?
Yeah.
Sometimes I wonder if doing this is a good idea. Because I think they go, oh, that's a good idea. I'm going to do that. It's like when you say to a kid, don't touch that. So what do? Touch it. Ooh, I never thought about touching it before, but now I'm going to touch it.
Do it.
Don't do this. I know, I'm afraid. This is what they do. They go, if I said like the average velocity from 0 to 5, they go, oh, well, it starts at 0, it ends at 4, so the average is 2 times 5 is 10.
I didn't know how you did that, so that's okay.
Yeah.
I have no clue how you did that, so.
Oh, yeah, I know.
The initial is 0. The final is 4, so 0 and 4 is 4. Divided by 2 is 2. times by a distance of 5.
Oh, because there's a triangle and a rectangle and you're supposed to do both.
Right. Here's the problem with that. What if the graph is like this?
I don't know, we're gonna have to like that, Mr. Bennett.
Right? And it starts at 0 here. Right? Let's say this is 4 and this is 0. So it's at 0 for like an instant, and then the vast majority of the time it's 4. You're telling me the average is 2? It's like getting 0 on one test and then getting 40, 40, 40, 40, 40, 40, 40, 40, 40, 40, 40, 40, 40, 40 on like 57 other tests, and your average is 2?
Yeah.
20, but yeah.
No. Or 20. Yeah, your average is 20. No? Huh? No. Your average is going to be like 38 point something, right? That's the difference here. Because the time is much longer at 4. Okay? So, how the heck do we do it then, Mr. Bennett? That's the wrong way, remember? How the heck do we do it properly? You find the displacement using the area under the curve technique, and then simply divide by the time. So for example, the average velocity for the time interval A and B, which is from 0 to 5 seconds, what was our displacement from 0 to 5? From before, just it was on the previous page.
Oh, right, okay, you're 16 meters.
Right? It was 16, right? Right? It was 16. So we're simply going to take that, there it is there, right? We're going to take 16, and we're going to divide by 5. The average velocity is 3.2. And if you look at that, it kind of makes sense, right? Because it starts at 0, goes up to 4. What speed is it at the longest? It's at 4 for a long time, right? I mean, it is at 1, 2, 3, it goes up to 4, but it's at 4 the longest. In fact, I'm almost surprised that it's not closer to 4. Okay, so here's question number 1. Determine the average velocity for the entire trip to 1 decimal place with proper rounding. With proper rounding for the entire trip. So you have to figure out what the displacement is for the whole thing. Fortunately, we've done all those. Some of you did them wrong. Maybe we should go back and give you the answers. Interval C is?
4. Oh, yeah, 4 meters.
Interval C is 4. Interval E is negative 7.5. Interval F is minus 4.5. Does the negative matter? Like when you're going? So you add them up, and you divide by the total time, which is 14 seconds. How do we find the average velocity? Find the displacement, divide by the total time. Okay, now we did these yesterday, but we might as well do them while we got the clickers out. So let's just try them here. So I'm asking you for the V-inst at 13 seconds.
Oh, no.
Is that
Yeah.
the same graph?
This is the same graph we've been using all along. V-inst at 13 seconds. How do you find V-inst?
We learned that yesterday, right?
At 13, 1 second? 13 seconds.
We learned that yesterday. I think.
Yeah, we did, right?
I kind of forget.
Alright, look at this right here. Look, really read what it says.
How would I rate that?
Look at the example I even drew.
We did it yesterday, yeah. This should be a really quick one.
13. Oh, I'm so sorry.
Correct answer is? Well, it sure looks like it's going to be -1, doesn't it?
Watch is not gonna be.
Yes, you're just reading it off the graph, right? -1. What about instantaneous acceleration? How do we do that? Again, acceleration is the slope of the position time graph. So at 12 seconds, what is the slope? 12 seconds, what is the slope? Okay, well, let's do it, I guess, but I know the answer is going to be 1. How do you find slope? y2 minus y1, so that's going to be 0 minus a minus 3, which is plus 3. And your time is always positive, 14 minus 11. 3 over 3 is what? Okay. Let's look at these next 2 pages. These next 2 pages are the most important 2 pages you've gotten probably all year. Okay, so listen real carefully. I wish I could figure out a way to... Actually, Mr. Smigalski had a real nice way of condensing this. I'll have to get that from him. This is like the mega cheat sheet for these graphs. Okay? So you'll notice that it's 2 pages. I only have 1 page up here at a time, right? But the entire left column is for... What does it say at the top? Position time. And does it say it at the top of the next page? Put your 2 pages side by side. Open the booklet right up. Put your 2 pages side by side. Okay? So down the left-hand column it says position time graph. So here's how you do everything on a position time graph. You can use this sheet as a cheat sheet for the next few graphs. If you're asked to find displacement, what do? Right? You read the final position and the initial position and you read them off a graph. This is for a position time graph. If you're asked to find average velocity on a position time graph is the slope. And if you're asked if it's a straight line graph, what do? Find the slope. What if it's a curved line graph? No, not a tangent, because it's average velocity, so you connect the endpoints and find the slope. That's average velocity. If it's instantaneous velocity and it's a straight line, we're talking about a single point. So you find the slope. If you're talking about a curved graph, that's when you do the tangent line. Make sense? Are you going to use this sheet as a resource?
Oh, yes.
Okay, on the second page, if you're asked to find average acceleration from a position time graph, you say, can't be done. It's too far down the integrate or too far down the derivatives, right? You can't find it. What about instantaneous acceleration? Can't be done. Okay, go back to the first page. Velocity time graphs. How do you find displacement? You have to look for the area. So it's this kind of deal, right? Finding area. How do we find average velocity? Use v bar equals d over t, where d is calculated as shown in number 1, right? So it's basically it's the area divided by the time. If you're asked to find instantaneous velocity, it's easy. You simply read it off the graph. If you've got a velocity time graph and you're asked to find average acceleration and it's a straight line graph, find the slope. If it's a curved line graph, find the slope, but joining the endpoints. If you're asked to find instantaneous acceleration and it's a straight line graph, find the slope, because the slope doesn't change. And if it's a curved line graph, you have to draw a tangent. A lot of information there, right? Makes perfectly good sense to me because I've done it for years and years and years and years. You don't have years and years and years to do it. You have days and days and days. So you're going to have to make the most of those days and days and days, right? All right, so yesterday I gave you some to do, like the first like A to F or something rather, right? You should be able to do all parts of all 4 graphs now. Should you do them all?
Yep. No.
Probably.
Holy.
I would think very few of you can do like just a little bit and it'll be okay, right? I would strongly suggest you do all 4. You do have answers and solutions on the back page. I have one more when you're done to give you as a hand-in checkup kind of deal.
Delta X is the displacement.
Delta X is also displacement, yes. Delta G. I should fix those.